Now remember, to use the sine rule, we are looking for a non-right angled triangle. So in this question, we need to identify our triangle, and we're not necessarily looking for triangles as we have in the past where we would have created or recognised a right angle. So have a look at it. Ian sails on a bearing of 163 degrees from A to B. This follows nicely from the exercise on bearings for 31 nautical miles. He then sails on a bearing of 195 to C, where he's directly south of A. There's so much to highlight there. I think bearing from A, and the numbers of course we'll put on our diagram. He then sails on another bearing. We've got a second bearing of 195 to C, and at that point he's got to be directly south of A. Now this becomes quite complicated. In part A, draw the triangle showing this information and explain why angle ABC is 148. I'm going to pause the video and suggest that you do also now, and then I'll draw the diagram and come back, and that'll give you an opportunity also to attempt to draw the diagram. Don't shy away from this. This is exactly the sorts of thing that you will need to do in an exam, an assessment task. Be able to draw your own diagram. Don't always rely on my diagrams or think that you will be provided with the diagram, because there'll be times when you possibly won't. So I'm pausing the video now. So I'll just explain the diagram that I've created now. So A is the point that the bearing is initially given from, on an angle of 163 degrees, as indicated here. Means it would be approximately in this direction, down to B, for 31 nautical miles. The length of that red line is 31. He then sails on a bearing, so I've had to create another set of compass points, north, south, east and west. And this time he's travelling on a bearing of 195. So clearly that's greater than 180. So we're around in this quadrant here, and it heads off in that direction. We don't know how far that is, but we know it is until he's directly south of A. Directly south of A is along this compass line, and I've indicated C occurs here. Now, that's the diagram showing the information. To explain why angle ABC is 148 requires a lot of steps. Now, I'm just going to work through the process and put in angles as I can find them, and you could pause the video at any time that you don't really understand why I've come up with the angles I have. Just rewind it and listen again. So, like I said, I'm just going to start wherever I can. I know that up here, and although it's not, so angle ABC, by the way, is this angle here. So I'm ultimately trying to show angle A to B to C. This red angle is 148. Now I'm not going to start down here at 148 because I don't have a lot going on there. However, I'll start up here with the 163. That will give me an angle inside here of what's 180? Take away 163 to get this angle in here is an angle of 17. So this angle in here is 17 degrees. Sorry. What I'm going to get from there, and again there's many different ways you can head from here, but what I can actually see happening is I've actually got, no, I want to go back to black. I've got a north-south line over here with A on it. I've got a north-south line over here with B on it. I've got a line joining them. Now, what I know about any north-south is they're parallel. Two parallel lines cut by a transversal. What do we know? We know that this angle and this angle are going to be equal. So that's using my two parallel lines cut by a transversal, vertically opposite angles are equal. So here they are. My 17 in here is equal to my 17 in there. Why would I do that? Because I can now see occurring at B is a north-south line. Here is B. I've got a west line. And I've got a line coming in and 17 up there. Part of the angle that I'm trying to find is this, which I can now find because that is 90. Doing 90 subtract 17, which will give me 73. So the angle in here is 73. Now, like I said, at any time you pause the video. Again, I need to find this dot, just like I was doing dots in class for angles. What I know now is that I can see I've got a 270 degrees all the way around to there. However, I've got a red line coming out here, and that much of it to there measures 195. If I can work out the difference between 195 to 270, then I'll have the size of the angle in there, which is my dot. And 270 subtract 195 is actually 75 degrees. Now, if I think about angle ABC, it's made up in my diagram of 73 plus 75, and when I add those two together, I get 148 as required. Now in part C, it says calculate how far south Ian has travelled. Give your answer to the nearest nautical mile. Now, at any time you're feeling like your diagram's getting too cluttered, then redraw it just like I have here. So I've gone from A, actually I'll change that from a T to a C. This is C, that there was a B, sorry about this, but that was point B, and so this would actually be lowercase b. The distance that Ian has travelled south is just this component of the triangle. So the total distance he will have travelled is of course this 31 plus this, but just the south aspect of that is this part of the triangle only. So it's like we wanted to find B. We know that this angle, what information have we got? So angle 148, which we've just found, is called angle B. So I've got a pair, a side, opposite, and angle. I could start to build my sine rule. I've got sine on sine B. Have I got C? Yes, I have. But do I have angle C? Not yet, not yet. How am I going to find angle C? Well, from the original diagram, this was 17. To get angle C, I would simply do angle sum of a triangle, which is 180, subtract 148, subtract 31. I don't know where I got that, 31. Oh, that was the length of the side. It's actually angle 17. So 180 subtract 48 subtract 17 gives us 15 degrees. So now I can complete my sine rule. B is the unknown side, the distance travelled south. Sine 148 is equal to C is 31 on the sine of 15. Again, I'll pause the video because you can see that I've created an equation. There is only one unknown, and I'll cross multiply and solve. So from there you can see that I've cross multiplied B sine 15. I want this B by itself, so I'm going to divide both sides by sine 15, and on the right hand side my 31 sine 148 divide by sine 15. And now you can see I've gone to the calculator, crossing those out. Sorry, I can just get the calculator and I'll drag it down. Now again, I've used the fraction facility on the calculator. You can see I've got exactly 31 sine 148 on sine 15, and we're getting this 63.47. What were we asked? To the nearest nautical mile, which is straight 63. Don't cut the 7 off and round the 5 up, and then cut the 5 up and off and round the 4 up. No, it doesn't work like that. Think about that as 47. 47 is less than 50, which would be halfway, and anything less than 50 doesn't require a round up. So we've got 36 nautical miles travelled south. Just a little reminder, there about northeast, southeast, southwest being exactly 45 degrees. That probably comes up here somewhere in these questions. And you should be able to get started on exercise 504.